Hello and welcome. Today we're going to be talking about how to build your own chips. And I've got some links on our week 6 page here. So let's go click this little guy. What that's going to take us to is a page that looks like this. It's actually the chip that we've picked, the 74HCT04. And what I am looking for right now is going to be what's inside the chip. Here we go. So this is the logic inside the chip. There are 1, 2, 3, 4, 5, 6 inverters or NOT gates. And we're going to be building this chip and putting those NOT gates in there. And we're going to use the pin layout that's right here. Now this is what we would call the technical information or the data sheet. And so anytime you're faced with a chip, you can find the little number on the top and you can go look up that chip and see what's actually in there. So this is a hex inverter, and all the information about how to use the chip will be in the tech data. So let's go to it. Next thing we're going to need to do is pop up our our Logisim. So I've got one here. I'll move this over a little bit. All right, so we need to set up our 6 inverters. And I will do that right now. So I'm just going to go to 6. There's 1, 2, 3, 4, 5, and 6. All right. And now we want to look and see what pins they're on. They're on pins 1 and 2, 3 and 4, 5 and 6. So I'm going to probably rearrange these a little bit differently here. And you'll see why here in just a second. All right, so these are going to be the actual input-output pins on our chip. So there's pins 1 and 2. Here are 3 and 4, 5, 6, and there's actually 14 pins on this chip, as I recall. So there's 1 through 7 here, and there's 6 through 14 here. Pin 7 is the ground, and pin 14 is VCC. So our gates lay out something like this on the inside. Set pin 1 and 2. And I'm going to end up changing those to output pins here in just a second. So if you click on these, you can change those to outputs. I'll just put yes. Output yes. All right, I need to label these two at some point in time, so let's just go do that. This is just going to be pin 1, and I'm going to call it 1A to match what's here. This is going to be 1Y. It's pretty typical for chips to use Y as outputs. So you'll see that, I'm sure, as you go through this. I'll call that one ground. And then we've got the other side to do. I'm going to copy these guys. And I'm going to move them over the other side. Now, when you do this, you have to make sure that you flip these around. Right now, they're all facing east, and I need them to face west. There we go. And I've already messed up. So pin 14 is supposed to be VCC. And so I'm going to grab that guy, stick that up there. Move all these down. Oops. There we go. All right, so that's the basic layout. I will label these here in a second, but I'm going to see if I can't shrink these up just a little bit. And we need to go through and give these all pin numbers. VCC. Or I shouldn't say pin numbers, pin labels. All right, so that's how the inside of my chip is laid out. Now, we're actually going to turn this into a chip, and we'll have to do a couple things for it. Up here on the top, if you notice, there's a little thing that looks like an IC chip. We are going to click that, and it actually put it on a chip real similar to the one you're looking for over here. Or looking at over here. So it is laid out appropriately. You'll notice this little green thing right here. This just tells it where its anchor point is. It really won't make a whole lot of difference to you, but that will be the place that it tries to center up on the dots. So everything else should fall into place, but that's the anchor point for the chip. You can move it around if you want, but you probably won't notice it acts a whole lot different. This part right here is the part that tells you that the pin to the left is pin 1. So this is pin 1, pin 2, all the way down to pin 7. That's our ground. Now, I'm going to go back here, and I'm going to add a circuit, and I'm going to call this 74 HCT04. I'll go back to main, and I'm going to grab all of this circuitry. I'm going to control copy, double click on HCT 74 HCT04, and I'm going to paste control V. There we go. And if I click that, you'll see that, yep, our chip is actually here. I'll go back to main. We don't need this anymore. If I make another chip, I may keep the layout. I did notice something here. I've still got these labels on the left side. I should be able to change this all to the right. There we go. Alrighty then, let's go back to 74 HCT. So there's our chip. We'll typically look at it in this logic state, so you can see the individual gates. But when we build bigger circuits, it's easier to build them here. And I'm going to go to the main. I'm just going to pull this out of the way for right now. Oops, thought I had it all picked. All right, so when we actually build circuits using the chips, we are going to single click one time on the chip we want, and we can put it on the page. And now you can actually make it work. Let's go with we'll add a button out here, and I'll add an LED. The LED is on the left, so I'm going to flip it around. All right. Now the VCC and the ground pins, we don't actually have to hook up. Let's go to run. All right, so I can push my button. And since this inverter does the opposite of the button press, right now we're not sending any electricity to the chip, but it is sending electricity out. It's doing the opposite. If I push the button, which would make it send 5 volts to the chip, the output goes to 0. And we can hook up as many of these as we'd like. Yeah, maybe I'll get them all. So here, I've got a couple of them hooked up. I'll go back to run, and you'll see that they still work. Now, if you put your mouse over the pins on the chip, you'll see that it tells you which ones they are. I'm not going to give you the pin number in this case, but it does give you the function. All right, let's go a little bit further, and let's give this thing a shared label. So I'm going to copy this one. And you'll notice that the chip number shows up on the chip, real similar to what it would in real life, where they're printed on there. And we could put that on as a label as well. But I typically just use the shared label. We could use, like the label, we could just say hex inverter, or we could just leave it off, which is typically what I do. Whatever is the most helpful. So if we wanted to put another one on there, we could. We would click one time, and we could put another one out there. And we could wire the output of one into the input of the other. Let's go get us a button. And you can see when we press this, it changes the input here, which actually changes the output, even though I don't have anything hooked up to it right now. All right, so that's basically how you build a chip. A couple things I want to show you here. Now, I purposely put these in the order they are on the chip. If you will do that, it will draw the chip out like it's supposed to be. I purposely put these ones with the inputs or outputs facing to the west, and the ones on this side facing to the east. This is how it knows which side to put the inputs and outputs on. Anything it sees facing east, it's going to try to put on the left side of the chip. Anything it sees facing west, it's going to try to put on the right side of the chip. And I can show you what that looks like if I change one of these. So let's go over here, and I'll change that to east. Oops. Yeah, should have been east, right? Okay, there it goes. You'll see the little dot, it's actually on the east, but if I go look at the chip now, it's got one more on this side than it does on the other side. So it simply uses the east and west to figure that out. Oh, by the way, if you're in chip view and you want to go back to circuit view, click this little icon here. All right, so we are going to build the 3 chips that are on the page. Let's go back here. This is our NOT gate, our hex NOT gate. This is our AND gate, and this is our OR gate. They'll have different numbers of gates on them, but I think each one of them is still 14 pins. So for any questions, get a hold of me. Hopefully you found this really helpful, and we will use some of these in our upcoming labs class. All right, have a great day. All right, guys, that's a wrap.